Hello, my name is Yao, and this is my video pitch for Assessment 3. In this video, I'm going to talk about 3 quiz questions from the past quizzes, including my reflection and some related concepts. But first, let me show you my photo ID to prove my identity. As you can see, this is my passport. And then I'm going to do a quick demo for how I locate the 5 quiz questions. Okay, now we have the questions. The 3 questions that I'm going to talk about today is Quiz 2 Question 2, Quiz 2 Question 3, and Quiz 5 Question 2. Now, let's move on to the main topic of today. So for the first question, let us recall some basic concepts first. In a machine learning process, there are 4 major players: the data distribution, hypothesis space, a learning algorithm, and the well-defined criterion. In machine learning, we assume the distribution of observed samples can sufficiently represent the data distribution of the entire population. All the patterns we desire to discover is with respect to the data distribution. They are the solid facts which can only be observed but not determined. So option 4 is wrong. The hypothesis space is a set of candidate functions that map input x to target y. In this question, Alice decided the structure of all possible functions in the form of a times xa plus b times xb plus c to approximate y. Therefore, she has determined the hypothesis space. So option 2 is correct. Then, with respect to a well-defined criterion, a learning algorithm is used to search the entire hypothesis space and output the best hypothesis that best describes the target y. In this question, Alice has not decided how to search in the space yet. There could be different ways to search it using different learning algorithms, so option 1 is wrong. Lastly, how xa and xb related to y can only be determined when the experimental test is done to validate and verify the results produced by the learning algorithm. Therefore, option 3 is also wrong. So for this question, the multiple linear regression model using gradient descent algorithm is suitable to model the linear relationship between xa, xb, and the target y. Now, let's move on to the next question. We already know a learning algorithm uses a selection criterion to find the best hypothesis from all candidates. Let's recall from the previous question. The data distribution of the entire population remains unknown. We can only observe the distribution from the sample data instead. Therefore, it is impossible to evaluate the selection criterion over the data distribution, but only over the available sample data we have. So option 3 is correct, and on the contrary, option 4 is incorrect. Moreover, in order to evaluate how well each hypothesis and find the best one that best describes the target y, the selection criterion cannot be the real-world performance determined by the task. This is because it is unstable and unreliable. In real-world environment, things happen in an unplanned and unpredictable way. A candidate hypothesis can sometimes work very well for one certain group of instances, but sometimes not due to so many unstable factors, such as data distribution drift. Therefore, option 2 is wrong. Instead, we evaluate each candidate hypothesis over a fixed training set using a method called loss function. A loss function is also called an error function that measures how far apart the predicted value deviates from the true value. It is determined by the model designer. For instance, for regression problems, models such as multiple linear regression often uses mean squared error as its loss function. And on the other hand, a logistic regression model uses the log loss function, also called cross-entropy, as its loss function. The hypothesis that minimizes the loss function would then be considered to be the best one. Therefore, option 1 is correct. Now let's move on to the last question. The decision tree follows a top-down hierarchical tree-like structure, which consists a series of nodes. As you can see, there are 2 types of nodes, decision nodes and leaf nodes. Each decision node contains an attribute checking and split the training samples into smaller subsets, and the leaf node represents a decision or a class label. the core idea is to ensure that the subsets becomes more pure or more homogeneous after each split, as we also become more certain about the prediction. Decision trees often use entropy and Guinea impurity to compare the class distribution before and after the split. Both of them are measures of disorder or uncertainty within a node. When all instances in a node belong to one class, we are certain about the target prediction, and the decision can then be made. In this case, the node will become a leaf node. For S1, intuitively we know it is true, but let's prove it. Before splitting, the probability for both classes, yes and no, is 0.5. Let's use Guinea impurity for example. Using the formula, we can get 0.5, which is the worst we can get. After splitting, the Guinea impurity in the child node becomes 0.095. You can see that after splitting, the uncertainty is much reduced in one of the child nodes. Therefore, it is true that the attribute checking makes the target less uncertain after splitting. For S2, when the probability of yes and no is 0 and 1 in a node, it means both its Guinea impurity and entropy are 0, and there cannot be further reduced because it's the lowest. This happens when all instances belong to one class in node only, and this node will be a leaf node with its decision to be yes. Therefore, S2 is also true. Then we know the option 4 is correct. And this is the end of my presentation. Thank you for listening.